Okay, question number 3. So Q of x is the addition of these two, the maximal domain and the range of Q. So if I consider both of them separately, the domain of the addition will be the intersection of the domain of each. Well, they both have to exist. This one here will shoot like this, where that says x equals -1. Therefore, it's from -infinity to 1. This one here, because the x can be squared, it's going to look like that. That's going to be -1. So the only domain that I'm going to have that satisfies both of them is -infinity to -1 for my domain. And of course, my range for my logarithms will be all real numbers. And I've graphed it, and that confers with what I can see over here. Okay, find the equation to the tangent to the graph of Q when x equals -2. Okay, so I'm going to come over here. It's a 1-mark question, interactive calculation, line, tan line, at x equals -2. And I'm going to have y equals -x -2. I can confirm that by doing sketch, line, tangent at -2. It drew it, and when I press XE, it gives me the equation down the bottom, which confirms. Find the equation of the line that is perpendicular to the graph when x equals -2 and passes through this point. Okay, so I'm looking for perpendicular. The gradient of this is -1. Therefore, the gradient of my tangent is 1 and goes through this point here. Goes through at -2 and 0, gradient of 1. Therefore, I'm looking for y equals x plus 2 to be my answer. Okay, let p of x equal this exponential. Explain what p is, not one-to-one function. Okay, for a one-to-one function, each x has a unique y, and each y has a unique x. So if we look for e to the -2x minus 2e to the -x plus 1, and have a look at that graph. I can see that it is not. P is many to 1, i.e. Y equals a half has 2 x values. So if I go analysis, no, I want a half, don't I? So 0.5. Analysis G cell intersection, -0.54, x equals -0.54, and x equals 1.28. So I know it's only 1 mark, but I'll give them the reasons. Okay, find the gradient of the tangent to this graph at x equals a. So the gradient of the tangent of this graph at x equals a. So I've got this graph. So I'm going to take the derivative. And then I'm going to make x equal a. And it's going to be gradient at x equals a will be e to the -2a times 2e to the a minus 2. The diagram below shows part of the graph of P and the line x equals x plus 2. That's the line we had before, and this is P. The line of the tangent at P so if I've got a tangent and that's when x equals a. Okay. Find the values of a which give theta to be 60 degrees. So we're looking at this being theta. And I want that to be 60 degrees. The acute angle between it to be 60 degrees. Okay, so I can have this line and the tangent, and that can be 60 degrees. Or I can have that line and the tangent and the angle, the angle will be 120 degrees because 60 degrees will be on the other side. I've drawn that badly, but what I'm trying to suggest is that there are two ways I can get this answer. I can have the angle between them being 60 or 120. So if I was to draw this again, this is my line of y equals x plus 2, and if my q value gave me a tangent line like this, where that was 120 degrees, then I would have 60 degrees over there. Okay, so if I have y equals x plus 2 and I have my tangent, I know that this angle here, beta, that tan of beta will equal the gradient, which is 1. So beta equals 45 degrees. So that's 45 degrees. If this down here is 15 degrees, then that will give me one example. But it can also be 120 minus 45. It can be 75 degrees. And that will give me this situation. Because I'm looking for theta, where theta is the acute angle between them. And between any two lines, I can have an acute angle or an obtuse angle. This is 60, and this is 60. Okay, so I'm looking for, I know the gradient of that line is what they got me to calculate over here. There it is there. That's why they asked me to do that. So I'm going to have that, and there it is. And I want 15 degrees to equal the inverse tan of the gradient, or 75 degrees to equal the inverse tan of the gradient. I'll accept either of them. My angle is down here and my gradient's negative. I want this to be negative 15 or negative 75, which means I want the tan of negative 15 or the tan of negative 75. So the tan of negative 15 gives me an A value of negative 0.11302, or negative 0.67021, and I'm doing this to how many decimal places? 2, so A can equal negative 0.11 or negative 0.67. And now looking at the last bit of the question, what's the last bit of the question ask? Find the x-coordinate, the point of intersection between this line and the graph of P, and hence find the area bound by this, the graph of P, and the x-axis. So I'm looking for P, that line, and the x-axis. So I'm looking for all of that. Correct? So it should be two integrals. It should be one integral, which will just be x plus 2 from -2 to the intersection point, dx, plus the integral from that intersection point through into 0 of p of x dx. So I've loaded all that onto the calculator from -2 to -0.75 of x plus 2 dx, then plus -0.75 to 0 of p of x dx, and that gives me an area of 1.038 units squared, which seems like a pretty straightforward 3-mark question to end this question.